What time is it? It's science time!
Oh, it's science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Working together with my crew makes learning so much fun. Actually, you should join us. Let's give science a try with a simple DIY.
Today, we're learning about flight. What time is it? It's science time! Oh, hey everybody! Welcome back to DIY Science Time. My name's Mr. C, and I'm super excited that you're here to be part of our crew today. Today, we're talking about flight. That's right, flight. Bernoulli's principle, and basically we're going to be making lots of airplanes and having lots of fun tossing those airplanes as we explore flight and how it works. But I want to show you something else that I have here also. So we just saw what was going on. This hairdryer is able to lift up this ping pong ball. And when I turn it off, it falls back down to the ground because gravity is pulling it down. This hairdryer is providing lift and it's creating a zone of less pressure where the ball is able to lift up and it's able to float. But I can do that with a straw too. Check this out. If you have a ping pong ball and a straw, this is a really cool thing you can try. Now I'm going to put this on here, I'm going to get a stream of air going, and then I'm going to blow as hard as I can, and let's see if we can see the actual ping pong ball spinning. So here we go. Watch the logo and see how it spins. Well, that's why we have extra ping pong balls, because they've been rolling off the table. Did you see what was happening? The ball was literally spinning this direction. That's because the air that's coming out of the straw was pushing the ball up, and it's going over the top of the ball, and that creates a lower zone of pressure. That air pressure is lower up top because the air is moving faster, and the air underneath, it's not moving as quickly, so it has higher pressure, and it's able to hold the ping pong ball up. All right, let's give it another try. All right, so it's very difficult.
Let's try it a different way.
We know gravity is trying to pull this ball down, right? When I let it go, gravity pulls it down. But what if I take a little top of a soda bottle, I punched a hole in it, and I put a straw in it, and I sealed it off with some clay. Now, when I blow air into this, air is racing down. And the question I have for you is it going to push the ball out? So basically like shoot it out. All right, let's see what happens. Isn't that amazing? When I'm blowing air through this straw, air comes racing out, and the ball is right here. The air moves around the sides of the ball, creates a low zone of pressure. Then the air underneath it has more pressure, and it's pushing the ball up to the hole, and it's basically making it's like a suction cup to the top. One more time. That's so cool. And this is because of Bernoulli's principle. We have this change happening, and that is actually how an airplane is able to fly. So that's what we're exploring today. We're going to talk about flight and how Bernoulli's principle applies to flight.
Who is ready to take off with an air-defying activity today? Let's fabricate some fantastic flyers from hoops and straws. For this activity, you'll need paper, straws, scissors, tape. And don't forget, you'll need your swooping, soaring science notebook.
A science notebook is a tool that every scientist should have because it gives us a place to record all of our learning. Taking notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all of the data and information we've gathered during our experiments. Plus, It allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information during the show. I've already added a title and the list of materials for today's activity, but our crew is still going to have lots of information to collect and organize as we go through our experiments. Most importantly, the more you use a science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook already, download a copy of Mr. C's science notebook from the website.
It's time to build our first paper airplane. Paper airplanes are so much fun. When I was a kid, we would make 10, 20, 30 paper airplanes at once, and then we'd go on our balcony, we'd throw them off as far as we could, and then we would see which one went the farthest, take that design, and try to improve it. Today we're gonna build one of my favorite airplanes, this dart airplane. Well, it doesn't have the dart on the front. This one's a variation of it. But before we start building, look at this. We have 4 principles of flight. Lift is the first, and that allows the airplane to stay up in the air. The air is pushing up underneath the wings, and it allows it to kind of hang in the air as it goes. The opposite of that is weight. Because the airplane has weight, it wants to fall to the ground due to gravity. Now, to get an airplane to move forward, it needs thrust, something to push it that way. That's right, and that's what we use our muscles for. When we throw the airplane, right? That is the thrust we're applying. But then there's drag, and drag slows things down, and that's due to air resistance. The 4 of those things working together allows our airplane to fly, and that's what we're gonna do today. We're gonna build a few airplanes. Now, this airplane was made out of regular printer paper. I'm going to actually build our model airplane with this blue so that it's a little easier for you to see and follow along. And then I'm gonna build a whole bunch of white planes, and then we're gonna go somewhere and we're gonna fly them. So let's get started. First things first, I'm gonna fold this in half. I'm gonna try to be as precise as possible. I'm going to use my fingers to make the creases really fine. And I'm sort of just using the side of my nail to push down really good. So now I'm going to fold it again and try to keep the center right on that line. So now we have basically the body of our airplane, and now we're going to fold down the wings. And this becomes a preference for you. I'm going to fold my wings like this. You can try different designs, see which angle makes your plane fly the best. When I flip it over, I want that to be exactly the same. And there's our first airplane. Isn't that beautiful? Let's build a few more and then we'll test them inside and then we'll go and fly them outside. The printer paper is so much easier to fold. It's so much thinner. And here on my last one, I'm bending the nose back so it's gonna have a flat tip nose. I wanna see if that changes the way the airplane flies. All right, there we have it. We've made a whole bunch of airplanes and now it's time to test them. I have a little tester here. I just wanna test a few of them inside before we go find a bigger space. And I thought it'd be fun to turn this on. What I love about this is it's a gadget that basically when you turn it on, it spins these little motors. And when this goes through it, it's gonna grab it and hopefully shoot the airplane through. Let's give it a try. And what I like about this is it allows us to see what happens with consistent power or thrust for the airplane.
Take your airplane and head outside to give it a test. Your airplane flies because of thrust and lift. Thrust moves the plane forward, while lift holds the plane in the air. Two other forces act on the plane as well. Drag, also known as air resistance, slows the plane down as it moves through the air, and gravity is always pulling the mass of the plane down towards Earth. Keep these four forces in mind as you improve the design of your planes. How far do you think you can get a paper airplane to fly? Whee! We're gonna give this paper airplane a try. Are you ready? In 3, 2, 1. Oh, that was awesome. Let's see how far it went. It almost went half court completely. It's about a foot shy. That is awesome. I'm gonna see if I can throw it that way and how far it can go. Before I do it, I'm just gonna crease this really good. Make sure it's all creased. All right, here we go. 3, 2, 1. Whoa! That was awesome! That was so cool. It went 3/4 of the basketball court. 3/4. That is amazing. So I noticed on that one when I threw it, I actually grabbed it kind of more at the front instead of the back. So I think that might have helped. I'm gonna see if I can get it to go back. 3, 2, 1. That wasn't as good.
Did you know that the dimples on a golf ball help the ball go higher and farther? Modern golf balls can have between 300 and 500 dimples. These dimples help increase lift and reduce drag. Great shot. 4.
Hi everybody, I'm here with my science crew at the McWane Science Center, and we're excited to have some fun because we are building hoop gliders. Are you guys ready?
Yeah!
That's right, we're talking hoop gliders in flight today. And this simple experiment is something you can do at home with your science crew. So, what time is it?
Science time!
Let's get to flight.
The first part was brainstorming the design. For my design, I used 3 hoops that's made out of construction paper and a thick straw that lets air pass by.
My idea was 3 hoops with a big straw and construction paper for those 3 hoops.
My glider is made out of 4 hoops, a thick straw, and 2 sets of wings.
After brainstorming, we got to share our ideas with each other.
So what do you think? Do you think that is if it's a bigger straw, or do you think it's gonna like fly further?
I feel like it's gonna like catch more air, so like kind of go further.
Yeah, so it'll glide longer.
What do you have on your paper?
I kind of like have like 2 big ones, and it's kind of hanging upside down. I went with thick straw and construction paper because it's like more stiff and it kind of weighs a little.
I added another hoop in the middle because I'm hoping that it will make it like go longer, and then I added wings so that it can like stabilize it so it's not like turning and then it just falls.
We brainstormed, we discussed, and now we build.
So Cole, what are you doing here with your glider?
Well, I'm making a 3rd hoop in the middle because I'm hoping that it will make it like glide longer.
Okay.
And then after this, I'm gonna start working on the wing so it can help it like, so it doesn't like turn over and all that. And so it can like glide straight.
So you think that 3rd hoop is actually going to provide some more stability?
Yeah, probably.
Okay.
I don't know what time it is. I can help you in just a second.
I feel like you should
It works.
take off.
3, 2, 1. Oh my gosh, that was so awesome.
That was amazing. If I could change one thing, I would change the straw. because I feel like it weighs it too much and it just won't fly as far as without it.
My glider, it flew pretty well. It kept on turning. I think that sometimes it would go fast and sometimes it wouldn't go at all. I think one thing I would change about it is I wouldn't have as thick hoops as I have built.
I think my plane flew really well, flew about 10 feet. I think that's because I added an extra hoop and added some wings. I think this made it fly farther because with the extra hoop it can add more lift, and with the wings it stabilizes it more. Something I would change is probably making it a smaller straw, and maybe that would make it lighter so it could go farther.
That was awesome. You guys did a great job building your hoop gliders, and it was so much fun flying them. Something kids at home should give a try, don't you guys think?
Yeah!
Yeah, pretty awesome, pretty fun. One last time, let's take flight. What time is it?
Science time!
Those hoop flyers really are first class. I've added some additional vocabulary and a diagram to illustrate how a plane can fly. It's so cool that the same things that make our paper airplanes fly are the same principles that keep real airplanes flying in the sky thousands of feet in the air. Thanks, Bernoulli. I'm also really surprised that hoops can fly too. The hoop gliders the crew created are all so unique, and I'm sure you could design your own flying masterpiece. I'm wondering, does the location or size of the hoop impact how well the hoop glider will fly?
Helicopter spinners are a fun way to explore air resistance and drag. Once you let go of the helicopter, gravity immediately starts pulling the aircraft towards the ground. Air resistance is pushing back up on the wings of the helicopter as it is falling. The tilt forces the air to slide around the wings. This causes the helicopter to spin as it falls. Props for a good build.
For our next build, we're going to build something that can fly almost indefinitely. That's right, it's like a wing, and it's going to be pretty awesome. And this is how we do it. It starts with a piece of newspaper. So I have a piece of scrap newspaper here, and my newspaper actually happens to be about 11 inches wide, which is perfect because that's kind of what you want. So what we're going to do is we're going to cut a 2 1/4 inch strip off of my 11 inch wide newspaper to get the actual wing size before we do any folding. So I'm not using any scissors for this. I'm actually going to crease it and then crease it repeatedly. And this is going to cause the fibers at that crease to basically fall apart, and then it's going to tear apart perfectly. And after creasing it repeatedly, I'm going to carefully hold it on one edge. I'm just going to tear it. Voila! Success! Excellent. Speaking of newspapers, I used to be a newspaper delivery boy. That was my first job ever. If I would have known this then, I would have just been flying these things around all over town. All right, we have our first strip. Now what we're going to do is lay it down. I actually have a piece here on the end that I need to cut off. It's part of the other page, so it's kind of getting in the way. Just gonna clean this up. Now that I have the wing, its proper size, I'm going to measure in about 1 inch. So you can see right there, that's 1 inch. And then I'm just going to fold this up to get a nice little crease right there. Make a crease. So I know that's my inch mark. Doesn't have to be perfect, but you want it to be about 1 inch. Now we're not going to crease that repeatedly. And then on this one, I'm going to flip it over, go in 1 inch. And I'm just going to fold it like that. So I folded them in opposite directions, like that. And now what we have to do is we have to fold along these edges. And we're just going to do about 1/4 inch. We flip it over and we do it in the opposite direction. Now we have our fold here. Then we have our fold here. And that is our tumbler. Now, when I hold it, the thing is you might have to crease this here so it holds the wing. And if on these parts here, if you need to sort of round it, you can. There we go. And now when I drop it, it'll start to tumble if I drop it really high. There we go. Isn't that cool? So I'm gonna get my edges folded. See if it'll fall towards you guys. Oh, and it does. Now you're wondering, how can this glider, how can this wing fly infinitely? Well, here's the thing. Let me get that back. Here's the thing. When this falls, air is pushing up on the back and it's causing it to tumble. Now, if we can get air to keep pushing up on the back of that wing, it'll keep moving forward and flying forever. How do we do that? Ta-da! With this. This is going to be used to push air forwards, and it's going to allow this to tumble, and we're gonna push air underneath it so that it can lift. Now, it's really hard to do it inside the kitchen because there's not a lot of space, so I think we should go on another little field trip and give this tumbler wing a test. Oh, and by the way, if you don't have newspaper at your house, you can use it with paper as well. The thing is you'll notice that this is a little bit bigger than this tumbler wing, and that's because it's heavier. The paper is heavier, the printer paper, so it's going to need more space to catch the air so that it is able to fly and glide the same way. So, build one like this, make it bigger, or you can use the one that we made right here. Let's go. Let's try our newspaper wing. Whoops. Oh, it is going perfectly straight. Oh, that was so cool. Oh, once you get it, you can feel it. And as it turns, oh my gosh, I'm gonna try to turn it. Oh, that was amazing. Once you feel it, it just glides. You can feel exactly kind of how it's gonna behave. So if you want it to turn, you bring this closer to the wing and then it pushes air closer and it causes it to pivot. That was so cool.
This activity is one you might want to try outside. Grab a cup of water. Mr. C has added some color to his cup to help you see what's happening. Place one straw into the water and then point a second straw right over the top of the first. The second straw should be horizontal and perpendicular to the vertical straw. It should look like this. Now blow through the second straw and voila! You have a spray of water. Blowing through the horizontal straw creates a fast stream of air. That high-speed air creates a zone of low pressure above the straw. This decrease in air pressure above the straw allows the water to move up into the stream of air to create a mister. Mr. C just made a water mister. What a cool mister, Mr. C.
Mr. C, you sure do know how to wing it. All these flying experiments have me on cloud 9. Paper helicopter spinners and tumbler wings are so much fun to make. I've added a chart to collect data for how they fly. You should try making them with different types of paper to see if that changes your results. Will your new designs be ready for takeoff? Roger, roger.
There we go. All right, that looks good. Everything looks good on my hoop glider. Looks just like the ones my science crew built. Ooh, I'm gonna test it here in a second. But before I do, wasn't today awesome? We learned about flight. We learned about lift. We learned about weight. We learned about thrust. And we learned about drag. Awesomeness. When it comes to building airplanes, you just have to know those 4 things, and those principles of flight will allow you to create airplanes or wings that are able to fly. And if you build a variation to any of these planes, make sure you hop online to download your DIY Science Time notebook. This will give you a place to jot down all the variations and let you remember which one worked the best. It's a great tool for any scientist that's learning about flight or any other concept. Whew! Today was awesome, wasn't it? Hoop gliders, whoosh. Dart planes, choo. 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 Whoa, those are getting close to the camera. And then we had our very own tumbler. I love learning about flight. I hope you soar to new heights. Keep learning, keep exploring, keep having fun, and remember, science is wherever you are. Take care, everybody. See ya.
It's science time.
All right, that looks good. Got my hoop glider, just like my crew dad. My crew dad.
It's science time.
Who dat? Who dat? That's my crew dad. In your notebook.
It's science time.
I'm gonna read. There we go.
It's science time. It's so much fun. Learning fun for everyone.
I couldn't get that to hit you.
It's science time.
I couldn't get it to hit you again if I wanted to.